I was asked to do a retrospective rather than of any new results, which is probably far more fun to listen to if I can get it right, but I'm going to try to do that. Essentially, I would like to give the impression, I first went there in the mid-70s, and these were joint service expeditions which had a couple of scientists along, and they lasted a good long time, and we got lots of results out. But I would like to give the impression that what has happened since, over the last 20 years at least, has been all part of a carefully planned, organized, well thought out program. But it hasn't. It's all been ad hoc. Every time we came back at the beginning, we never knew if we'd ever be able to get out there again. So it would be unkind to say it was sort of a muddle and a shambles, but what I can do now is to suggest that it was all part of a carefully planned operation lasting 20 years. We had several extended programs, and we noticed in the 70s, for example, that the reefs were very, very rich, but they were really not much different to most of the world. But then what David Bellamy, who started all this, called the decades of destruction happened, where I must say, most of my work isn't in Chagos, it's in other areas of the world, a lot of the basket cases and places which have a great deal of problems. I was asked in about 20 years ago to organize an expedition in 1996, which happened, and it was remarkably successful in the sense that people produced such a lot of material. We were able to produce the book courtesy of the Linnean Society. John Topp on the top right there, and David Bellamy, who began it all earlier, at the bottom there. It was usually a bit of a struggle to get expeditions going. There was not great enthusiasm at the time amongst either government or the military. We went to 1996, although it was successful, I have to say it was despite a lot of opposition. Nobody really wanted us to go there. It was the first time scientists had been there for a long time. Well, I never quite knew why. I think they thought that academics were sort of probably communist, probably unreliable, goodness knows what, anyway, but it was difficult. And when we got out there, we had open opposition from the military, and talking to some of the soldiers there, or Navy people there, we were told that they had instructions to not help us in any way at all. We corrected that afterwards by suggesting to the Foreign Office that the next one, if there was going to be one, we didn't know there was, should be organized through the French territory of Reunion. And of course, to mention to our government that we should get the French to help them organize it, that worked. But basically, we knew that Chagos remained very rich at a time when the Indian Ocean around the edges, and in the middle, a lot of it, was starting to collapse from overuse. My specialist area is corals, the coral cover, diversity, and a lot of population structures of them and so on. And we knew that in 1996 there'd been a bit of a decline. One or two, if anyone's interested in the corals, of the Acroporidae had died. We didn't know why. We really didn't know why. And it only became kind of obvious after a big wipeout that happened in 1998, which killed most of the corals in the Indian Ocean, that in fact there had been, as we now know, a lot of these small warming pulses that had killed off the corals, which are the ones which are most susceptible. And I've got a couple of pictures here to show you the kind of thing. My apologies for people who've seen this before, but what happened, if you get a warming event, this was one that happened later, that the corals simply die and then they turn into rubble. These were coral cover results, the percent coral cover results before that wipeout. And they were reasonably high. 40% you might think is less than half, but that is perfectly normal for a healthy oceanic reef. And after to start with, after 98, we contacted the buyout admin and said, it's happened everywhere else, it's probably had a major effect, this El Nino effect, on the reefs of the Chagos as well. We need to go out and see what they're like. And they said, no, of course it hasn't. And they got, at that time, a company had been contracted to do, well, other aspects of work down there, and they got the chap to report back whether there was a problem or not. And he said, no, there's no problem at all. So a friend of mine who was on the 96 expedition, Chaz Anderson, he had a friend in the Maldives. who acquired a camera, stuck it underwater, and sent back a roll of 36 shots, which showed complete desolation in the Chagos. So I got agreement to go out with John Top, and the site was just horrible. We recorded that amount of cover there, and we had a small expedition in 2001 to look at the recovery, but there wasn't any. It still stayed pretty dead. And it was only after then I was asked to be the scientific advisor. I should add that that role is really sort of town planning of Diego Garcia. My own interests in the other atolls are sort of separate from that. But it was not until about 2006 that we next went out as an expedition to see what was happening. Meanwhile, the reefs had turned into that kind of situation. And in 2006, it started to recover. Now that's, 8 years later. And then we know what happened now. Some of you have seen this before. We're going to do the cover again next March, but I'm afraid we had indications of a warming event this year, or last year as well, so I'm a bit anxious about what we're going to see in 1 or 2 areas. One thing we do know is that the coral recovery is going to be set back increasingly frequently by warming events. I mean, everybody who's looked at this has sort of published on that. But what was different about Chagos is here are 2 sets of results. Black is Chagos coral cover on average, showing that, yes, in the mid-90s, they were both about the same as the Seychelles. In 1998, they both got clobbered very badly. The Seychelles has stayed pretty bad, but Chagos has really bounced back to the same-ish as what it was before. And I think it's one of the fastest rates of recovery we've ever seen, and it can only be attributable, it's a salutary point, but it's attributable to the fact that there's no other impacts. There's no overfishing, no sewage on the reefs, and there's no disturbance of the shoreline and so on like that. And that graph can be mirrored by a lot of sites around the world, and we know that if you increase the number of different impacts, then recovery either doesn't happen at all or certainly happens very much slower. So that's the corals. I'll just come to fish biomass. At the same time, expeditions were kind of mounting. We managed to get more funding from places like the... well, there was a fund which was joint sort of DEFRA, or DFID rather, and the FCO, which is now defunct, taken over by Darwin. As more people came and realized what a remarkable place it was, so different people put out lots of grant applications, and we got plenty to go. And one I'm going to just simply touch on now is the fish, because it's quite a striking story, I think. Read the quote, but look at the date of the quote, 1969. The idea of sustainable fishing has been a thorn in a lot of people's sides for a long time. I've challenged people, tell me where there's been productive, sustainable fisheries on reefs, and no one can really show where. You've seen this picture. Look at the posters outside. The posters and the front pages of lots of papers outside. There's been 200 or 300 papers, so we photocopied off a few just to show you that we had done stuff, I guess, but a lot of them are out there. The Chagos archipelago is head and shoulders above everywhere else, even in the best sites of the Pacific and the Caribbean, incidentally, but not by much. But all the rest of the sites in the Indian Ocean, even the protected areas, even the managed areas, are struggling greatly. It's easy to sustain a very depressed state. You cannot, or nobody has yet, I don't think, show me if I'm wrong, sustained a biomass of fish somewhere between Chagos and all these ones that are bumping along the x-axis there. It just hasn't happened, either because the transition between rich and the rest happens very quickly, or perhaps they just haven't been seen yet, but we don't know of examples where you can have a productive, sustainable fishery, and partly the reason is because it's the big fish, which are most easily caught, which are the ones that lay the most eggs. We know that when you've had protected areas in Southeast Asia and things like that, and the protection's been relieved, or been abandoned, that the crash can happen within very, very few months. And also, alarmingly, and this is the frightening thing, it really doesn't need much to make it transit from the high level to the low level. And no one's really got a handle on that, but I do know a lot of our friends are working on that actively, and the results are quite kind of depressing. The other main theme that sort of evolved, carefully planned from way in for, is to show the connectivity of the place. A lot of work has shown that it is firmly part of the Western Indian Ocean. These are coral results. There's another set of results which show the speed of connection between the two. And these are falling. We've only got these two sets of results so far, but a lot more are in labs all around the world. In some cases, the movement is very slow, as in the zooanthellae, the algae in corals, as on the right. But on the left there, we know that the coconut crab migration between the two, especially going from the Seychelles and Africa to Chagos, because of when they breed and when the currents flow that way, is very high. So Chagos is a stepping stone, and it is, and the fish work, which I haven't shown here, shows that it's a stepping stone for a lot of species, and it is a recipient as well, if you like, a refuge, a reserve for a lot of Western Indian Ocean marine fauna as well. There's been a lot of other important factors which have been done along the way. I'm just going to whip through them now. You can read it yourself. Do read the posters, or have a look at the posters outside, which show a lot of the results we have got. I think on the website, it's probably out of date again, but a list of all the publications that have happened, and there's 200 to 300 of them now from people around the world. I should point out that there's been, I think I'll come to it slightly later, something like 60 scientists or more, 80 scientists have actually been there, but the number who've worked on Chagos, on the lab results, once we bring samples back and so on like that, it's more than sort of double that number. A couple of new developments are happening, and also there's a lot of modeling just kind of starting up. A question I get from governments all around the world, actually, is, well, what's going to happen in the future? So, hence modeling. We try and do the best we can to tell them what we think might happen. And the results from the IPCC are used, and what we know about the trends from institutions all around the world show us a bit more, and it's never terribly good. There's a few projects recently being started. This one is erosion of islands. As sea level rises, people either say it is or isn't happening. But one thing that happens is, of course, when the corals die, and there have been 2 or 3 bleaching events, not mortality events, but bleaching events post-1998 as well, and we know that corals will need about 3 years to recover enough in order to breed, for example. It sets them back. And erosion of a reef is about that much, and growth of a healthy reef is just a millimetre or 2 more every year. You stop the growth for a few years, you still get the erosion, so that you get sort of an attrition, if you like, of what is the breakwater. The coconut crabs were, of course, pretty well extirpated in a lot of places. Now we've got huge numbers where they've been measured, and it looks pretty much the same on lots of other islands. And there's some very big gaps which we've hardly started. Cryptic fauna, the growth of the corals itself, and so on. A huge new initiative is starting, funded by the Bertarellis. We had a meeting in Geneva not long ago to develop 5, what turned out to be 5 great themes, one of which is the pelagic fish work, one will be the reefs and islands work, one will be the outreach and PR work, and this sort of things. I think there'll be a bit more about that later on. But essentially, this could provide a framework for something much bigger. I think we've reached a state now when we've got a lot of information. It needs to be collated rather more. There's a sideline here just showing the pollution. It's been alluded to already. It's an extraordinarily clean place. A lot of people recognize it as valuable for research, and a lot of people, far more than can be taken there, unfortunately, say they would like to go and see what a real reef kind of looks like, what a reef of 50 years ago should be like. And this is especially important for people around the rim of the Indian Ocean, where the reefs are pretty badly shot, what they should do to manage to try and get them back again. Now, I think that management of a reef is just hubris. Nobody can manage fish, nobody can manage corals. What we can manage is human activity which messes them up. But that's not quite the same thing, and I think if that is made clear to people, they can realize, no, you're not managing a coral reef, you're just stopping people from messing it up. And if you do that, they can probably recover very well. And we think that that's the case. Oh, here's just, I'm probably running a little over. I'll just speed through that. This lead already existed, the Hawaii Marine Reserve. We'll hear more about this later on, I think, and the Big Ocean Network. We had meetings in Marseille just very recently to try to develop a cross-big MPA theme. IUCN are going to publish a document next year on the how-to, the why should you sort of approach to the whole thing. We're the only one in the Indian Ocean, of course. The way ahead, well, Anne actually collated, I think it's about a 25-page document of things which are underway or which needed to be done. That's also on the Chagos Trust website, and you can see it. This is just the first page, truncated. There's an awful lot of material. Issues, oops, that was wrong. I'll go back to that. Issues which need to be addressed. One of the major stresses on ecosystems is poaching. We know there's quite a bit. We have research students, ex-research students in Sri Lanka and so on, who go and ask the captains of ships, where did you go? And far too many are going to the Chagos Archipelago. It's an issue which would be expensive to tackle, but I think as this is a major stressor on reefs, it should be tackled rather better. First of all, sea cucumbers were poached a lot, and Andrew Price here did a lot of work on that. Then they seemed to be fished out, and people changed to sharks. When we first went there in 1996, the land parties found poacher camps on just about every island there. It was wide open. It still is wide open, too much too much, if you like. So how will we organize all this? I think now the sum of all the work we've got doesn't tell the story. If we can integrate this large amount of work in a proper way, we can get sort of a benefit across fertilization and go ahead further. Whatever the future holds, the environmental protection of such an unusual place, I think, is one of those that needs to be conserved. We know now that there's an alarmingly small amount of damage can mess it up. That has to be avoided, and it shouldn't be impossible to avoid it. Indeed, it has been avoided so far. Now, the difficult bit is how we're going to integrate all this. And that's the difficult bit. So I'm passing the buck now to Elisabeth, who is just going to run through a project that CCT is going to fund now, which is, well, as you will see.
Okay, thank you, Charles. Right, so this morning I'd like to share with you our vision for the Chagos Science Research Portal. And really there's three aims of this project. We are looking to compile all of the science from the last 4 decades, really, into one big relational database. We're also trying to make an easy way for new research to be deposited into this research, or into this database, and then connect the relational database to maps. And we see 3 main user groups using this resource. So first, researchers, and then decision makers, and also as a tool for public outreach and engagement. So this is just a schemata of the resource portal, and at the heart of it is the relational database. So this will really be the first port of call when people start to think about doing research in the Chagos Archipelago. They'll go to this relational database, see what's available, see what kind of gaps there might be in the available information that they could fill. And then once they've done their research, they'll then deposit the new data via a website, and that'll feed back into the relational database. The relational database will feed into a management toolbox or management toolkit. So things like biodiversity metrics and other indicators of ecosystem health will be calculated in this toolbox. And that'll really be a great tool for decision makers such as the Bayat administration to base their decisions on. And also the relational database will feed into a GIS interface, so a global information system. So by mapping this available data, it becomes a lot more interactive and gives a more comprehensive image of what's going on, really. And also, having it on a map, like a Google map type of interface, makes available data and also available media much more interactive, so it becomes much more available to the public. So what type of data are we going to be putting into this relational database? Well, all of these lovely photos here were taken by Anne, and they summarize the biotic data that's available. And there's lots of distribution, composition data for corals, soft corals, for algae, sea cucumbers, seagrass beds, and mangroves. And also, as we heard from Charles, there's a lot of fish data as well. And then if we move to the land side of things, we have lots of plant data, bird data, coconut crab data. And of course, we have the abiotic side, which includes island size, remote sensing data, so habitat maps, seagrass bed maps, and we have bathymetric features as well, so you can use different base maps to show what it looks like, well, the mountain range basically under the water, what that looks like and how it relates to the position of reefs and so on. And also things like earthquakes, tsunamis, warming events, those types of pulse impacts we can map. You see those little red dots right there. Those are the historical, well, those are earthquakes that have taken place in Chagos. And of course, human impacts, so fishing intensity, poaching estimates, rat density, and pollutant levels, those can also be part of this relational database. And oceanographic data, so sea surface temperatures. We have some great long-term records for the Chagos archipelago, so that will be able to be mapped as well. And finally, we'll have media. So media in the sense that researchers can use it, so things like photo quadrats and video transects that you can actually use to do research on, but also things more geared towards the public, such as Google Street View transects across the islands, and the Catlin Sea View is also planned in the future for the Chagos archipelago. And of course, each data entry has an author, and it also has a data source, so this will also be included. So we have lots of different data sources. Now comes the fun part of putting it all into a relational database. And so a relational database is a database where each entry, each piece of data, is related to another piece of data. So you draw all of these connections, and it becomes this overwhelming scheme. But what's really powerful about this is instead of just doing a simple keyword search that then returns, say, all the documents that contain that keyword search, you are searching through all of the relationships within this whole relational database, which makes it a far more powerful search tool for researchers to compile the data that they need to then inform future research. Right, and so each one of these pieces of data that have been collected were done at a certain place and at a certain time. As such, they have spatial and temporal coordinates. And because they have these coordinates, we can map them both in space and in time. And what we're proposing to do is to use, for any web development geeks out there, the Google Map API interface, and we're going to have what's called a MySQL relational database in the background. Okay, that's a technical bit. But what that allows you to do is to map each individual data point in space. And also, if you're familiar with Google Earth, you know that there's that little time bar slider up in the left-hand corner. So you'll be able to look how the data changes over time as well. And of course, you'll be able to click on, say, a particular reef and see what type of media is available for that. So that'll really help make it accessible to the public as well. So these type of GIS systems have been initiated in other parts of the world. E-Reefs is a big initiative by the Great Barrier Reef Foundation, and there are a lot of different contributors to that, including Microsoft. And the idea really is summarized by their tagline here. It's to summarize what was, what is, and what will be. So I think that that's really important for informing the best decision-making and the stewardship and research for the Chagos archipelago. Thank you.